Okay, I just stopped. I'm restarting. So we learned that these two are not logically equivalent. They don't mean the same thing. But if I keep this bar, parentheses, a plus b, but instead I decide I want to compare this to bar a, wedge bar b, this actually means the same thing as bar, parentheses, a plus b, close parentheses. And so if I do that, we need to make sure true, false, just like over here. You guys need to speak up if I do this wrong, okay? I know you're at home, but you can yell really loud and go back through time. And so we can have true, false, and then true, true, false, false. So we do the negative. False, true. And then wedge becomes false, wedge, false is false. True, wedge, false is true. False, wedge, true is true. And true, wedge, true is true. Which means in this case, line 1 is false here. Line 1 is false here. Line 1 is true here. Line 2 is true here. Line 3 is true here. Line 3 is true here. Line 4 is true here. Line 4 is true here. Meaning that on every single line, these have the same truth value. Which means saying it's not the case that Al and Bill will be here is the same as saying Al won't be here or Bill won't be here. And then it should make sense, I think, to most of you in your mind. That if I say it's not the case that both Al and Bill will be here, I am saying Al won't be here or Bill won't be here. I'm saying one of them won't be here. Maybe they both won't be here, but I'm at least not saying Al won't be here and Bill won't be here. I'm just saying Al won't be here or Bill won't be here. And those mean the same thing. And so this allows us to see when these statements mean the same thing, when they don't mean the same thing. We can determine when statements are logically consistent, when they're inconsistent, when they are logically equivalent, and when they are logically contradictory. And we can compare the statements. But the last and most important thing we can do with this is we can actually do what we call test validity using a truth table. And if we remember our definition, a valid argument is an argument in which, if the premises are true, then the conclusion necessarily must be true, right? So a valid argument is one in which, if the premises are true, the conclusion necessarily must be true. Now, what happens is if you have an argument in which, by doing a truth table on the premises, you find lines in which all the premises are true, but the conclusion is false, then you know you have an invalid argument. Now, if one of the premises is false and the other one's true, and the premise and the conclusion is false, that doesn't mean anything. If both the premises are false and the conclusion is true, that doesn't mean anything. If everything's false or everything's true, it doesn't mean anything. The only time it matters is if all the premises are true and the conclusion is false, then we know we have a logically invalid argument. So if we do a truth table in which we put all the premises and the conclusion, and we find the truth table or the truth value of each line of that, and we then find the truth value of the conclusion, and we find an example, like if we have A horseshoe B, bar A, bar B. This is a logically invalid, well, let's do a logically valid one first, okay? This is a very simple logically valid argument in which, we have TF, two letters, so we have that, TT, FF, A is TF, TF, B is TT, FF, right? And so then T horseshoe T is true, false horseshoe true is true, true horseshoe false is false, and false horseshoe false is true, right? So we circle this, the main operator. And we know now, true, 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 no problem. True, false, well, all the premises aren't true, so it doesn't matter. False, true, doesn't matter. They're not true, false, they're not, it doesn't matter. So we can't find one in which the premises are true and the conclusion is false. And so we would determine that this is valid. If you cannot find a line in which the premises are true and the conclusion is false, then we must label it as valid. But if we find a line in which the premises are true and the conclusion is false, then we have an invalid argument. So all we have to do is add bars on that, because this becomes what we call denying the antecedent. It's one of the formal fallacies that you need for your logic project. And so bar A becomes bar true, becomes false, true, false, true. And this one becomes false, false, true, true. And so what happens here is you look and you say, is there any one in which all the premises are true? Well, this one, they're true, and this one, they're true, right? Now, on one of these lines, line 1 or 2 or 4, there's a false conclusion there. And so that, because you have true premises and a false conclusion, that can't happen in a valid argument. And so we would then determine that it is invalid. Now, on the other hand, suppose you found one like this, where it's true, true, true. Well, that doesn't make any difference. And the fact that this line exists in this argument doesn't matter. All that matters is if there is one line in which it's possible for the premises to be true and the conclusion false, we know we have an invalid argument, and we label it as such. Now, the thing is this becomes a lot of T's and F's. And especially when you start having things like, A, horseshoe, B, wedge, bar, T, bar, L, and then you have, A, wedge, bar, L, and then you have, B as your conclusion, things like that. Well, this is going to be 1, 2, 3 unique variables. It's 8 lines. There's, so you're going to have 8 letters here, 16, 24. You're going to do that one, 30. You're going to do that one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 times 8 is 88 T's and F's. This can become fairly lengthy to do an entire truth table on. And so what happens is there is a thing called an indirect truth table. And I was just looking to see if you can really see this completely. But there is what we call an indirect truth table. And what an indirect truth table does is an indirect truth table basically says, let's assume the conclusion is false and the premises are true. Okay? If we do that, then what we can do is we can figure out what some of the values of the letters in these are. Well, we know B is false because that's the conclusion. So we can put B as false here. Right? Okay. And what we can do now is we can then say, okay, well, if this is true and that's false, is there a way that we can get these to be true and that to be false? Well, in this case, this becomes a little bit more complex. So I'm going to change one of these letters. I'm going to change this to a plus sign. I'm going to do it for a very simple reason, because it's going to make what we're doing here easier, okay? Now, the only way to have this plus be true is for the thing on the side of it to be true, which makes L false. And this would have to be true, which means the A would have to be false, right? So if A is false here, and L is false here, which would make the bar true, this works, and that works. And so therefore, this is an invalid argument. Why? Because we can find that it is possible. By working backwards, we can do it. Now, you don't have to do indirect truth tables. They are convenient at times, but you don't have to do it. And that is something you might want to look at and might want to take a little time to work on. But I also accept that this can be fairly complex. Some of you are going, you know what, I'd rather do 64 lines. I'd rather do 32 lines. I'd rather do 16 lines with 14 letters. I'd rather put 120 T's and F's on the line than sit here and do it. And that's fine. But there is an indirect method. The only thing is, and the reason I changed that plus to a wedge to a plus, was because in that case, if it was a wedge, it would be harder to determine what was true and what was false. And what would happen is you would actually have to do 2 or 3 different lines. And what happens is essentially what you're doing is you're trying to avoid doing all 8 lines. You're just looking for the key lines, the lines in which the premises could potentially be true and the conclusion false. And so you're looking specifically for that. Now, a couple notes worth making before the exam. You need to go through this, do problems, and do more problems. Double check them, triple check them. If you can do all these problems, you should do fine. Second of all, the exam is this exam I believe is completely multiple choice. And I might be wrong about that, but I think it's mainly multiple choice. But what it's going to ask you is things like, is this, when comparing these two statements, are they, are they logically equivalent, logically contradictory? And you'll have to do the entire truth table, but the question on the exam is simply true or false. It's simply one of the choices. First of all, some of them will be like things like, how many lines would you need to do this? And things like that. They're asking you how to set this up. Because if I actually asked you to do this entire truth table, that would be hard for you to do in a computer setting. You would have to sit there and type in all these T's and F's. The T's and F's would fall out of line. It would be very difficult. I haven't figured out a way to do this in a way that actually would be easily gradable through Blackboard. Perhaps there's probably logicians who have created systems, but we don't have that connected to Blackboard. So that's why it's a little bit more complicated on that level. Second of all, so some of the questions are a little bit different. If you can do these in the long form, you will be able to do well on the exam, and you will have to do that for the exam, but you won't actually fill it out. You won't actually put all these T's and F's into a empty box on Blackboard. So that's just a couple little notes there that you might want to be aware of. Second of all, and this is where we have an important point here. Second of all, what was the other thing I was going to say? Second of all, the other thing is one of the things that exists with this is that it is very easy to put a T or an F in the wrong place. Earlier, I think in one of the videos here in the last, I think it was the previous video, maybe it was the one before, I think I started joking about, you guys not telling me I was wrong, and the case is it's very easy in your rush to put T's and F's up there, to put a T where there should be an F, or to miss a line, or to get two lines confused with each other. And so one of the things you need to keep in mind is you need to keep a very close eye on your T's and F's. And if you get one out of place, it can mess up your entire thing. So one of the things I like about truth tables is, to a certain degree, a lot of us who are really good at logic or really good at things, or just maybe you're good at something, and you're very quick. Maybe you're good at crocheting. You can just, I know people like, I have an aunt who can sit there and do needle point or whatever, and just, cross stitch or whatever. And she does these amazing cross stitches, and, she can do, things that have been in international art shows. She's very good. And she can do it very quickly. But you know what? If you're not paying attention, you're really good. Sometimes you can make a mistake, and it can very quickly become a very big mistake, right? And because you're so quick, you're not paying attention to the little facts. And most of us, when we read, are like that. We give a lot of charity to the people we read, and we don't realize it. So one thing editors have to do is they have to slow down and make themselves read stuff so they're looking at every word and every letter and making sure it makes sense. And so one of the things, like when you're editing for like a newspaper or a magazine or something, one thing you do is you actually read like headlines backwards, because it actually forces you to look at each word and be more precise. And you do things like that. You stop on each word. You force yourself to examine the word. And the same thing is true here. You need to stop yourself, slow yourself down. Just because you get it, just because you're doing it quick, don't get in too big a rush, because that's going to be your number one problem, is you're going to get one T or one F out of place out of 132 T's and F's, and it's going to mess up the entire thing. And you're going to be mad, and you're going to be reasonably mad, but at the end of the day, the only person you have to be mad at is yourself, and I have been that person many a time, so don't think you're unique on that level, because I have many times done that. Okay? Any questions? Oh, yeah, back. Oh, wait, nobody came in. Never mind. All right, have a good day.